We're going to blow it up. Okay.
You're going to get some guy from down south calling you being like, how'd you do this with these kids all the time?
I love it. Okay. So, we are going to start today our wonderful world. Hmm? Mm-hmm. You ready? I don't know. Well, it'll be recorded for the world to hear. Okay. So, what chapter 9 is all about quadratics. And this will probably be our last chapter of the year. So we're going to look at quadratics and their properties. There's a lot of cool things with quadratics. So today what we're going to learn about, okay, is we're going to learn how to graph this and this. We're not going to learn about anything with the middle term as of yet. We're just going to worry about a leading term and then the two end terms, okay? Yeah, don't worry, you got your back. I am going to need you guys to come grab one piece of graph paper. So, please come grab one piece of graph paper. One piece.
I'm doing one to Jen.
Okay. Okay. After you sit down, whoa. Ladies and gents. So, key concept. And this is a major concept we have here, okay? The standard form of a quadratic function. Nick, please write this down. Thank you. If I don't like it, then I'll do it again. But you guys are usually better than my other one. Mm-hmm. So a quadratic function. What is a quadratic function? It is a function. Remember, a function means every input has exactly one output that can be written in the form of y equals ax squared plus bx plus c. And those are what we've been practicing factoring for like the last 3 sections, right? So they're important to us. We're using them more. Okay, quadratics are very helpful. Yes, ma'am. Yeah, that means a is not equal to 0. Very good. And the reason I said a can't equal 0, because if it equaled 0, would I have a quadratic anymore? Nope, because that leading term would go away and I'd be left at a linear. So that's why they say that. Yes. Yep, take the sign, please. It's what I have, so get over it. And here I have a picket sign. So there we go.
Reminds you to wash your hands.
So here's an example of a quadratic.
It's only 99.9 grams.
Yeah? What about, and then here's another one. It's also another example of a quadratic. Anything that has an x squared in it as the leading term, that's your quadratic. Your highest power is a square, you have a quadratic equation. Okay? Okay. So today our big goal is we're going to learn how to graph these. So what we need to first talk about is something called the parent function. Bless you. And a parent function for the for a quadratic is simply y equals x squared. So here's what I'd like you to do. Get one of those pieces of graph paper out for me. And by the first box, we're going to figure out what this looks like. Okay? So by your first box, I want you to write right over here y equals x squared, and then we're going to make a table. So we're going to figure out what this looks like. And the parent function is always going to look like this for a quadratic function. So let's put in a -2. So if I put a -2 in for x, so then y is going to equal -2 squared. Well, what's -2 squared?
-4.
Not -4. +4. Because a negative times a negative is a positive. So could you graph that point? So go backwards 2, up 1, 2, 3, 4. There's our point. We're going to do the same thing here for -1. So we're going to put that in for x. So it's -1 squared. 1. So let's plot that point. -1, 1. And do the same thing for 0. What's 0 squared? 0. So, crosses at 0, 0. And put a 1 in. What's 1 squared? 1. And then put a 2 in. 2 squared is 4. This is the parent function. This is the overall shape of a quadratic function. That's what it looks like. We've left straight line land. Awesome. Nope, can't use a ruler on this one. Don't be too excited about that though, whatever. Okay. This actually has a special shape, and on the graph that you just drew this on, I would like you to write the name of it. This is called a parabola.
That's a weird name. It reminds me of granola.
Kinda. So, that special shape is called a parabola. And another really cool thing about parabolas is they have something called the axis of symmetry. And what that means is if I drew a vertical line right here, what's true about the left side and the right side?
They're equal.
They're the same, right? So if I actually folded it over, they would land on each other. This vertical line, in this case, for the parent function, it's x equals 0. So on your graph, I want you to draw a dotted line along the y-axis. And right above it, write the equation x equals 0, because that's that line. And this is called the axis of symmetry. Yes.
If we used different numbers for x, would it still be 0?
Yes. And the thing with parabolas is you got to make sure that you can see both parts of the U. So like if you only picked numbers out here, would you see all of the shape of the graph? No. And that's just something we get better at by practicing. Some other cool things is, what do you think we call this point right here where it changed from going down to going up? That is called the vertex. So there's a lot of stuff we refer to when we talk about parabolas. There's a lot going on with it, right? Now, sometimes, so go back to your note page. With the vertex, there's a couple things we need to talk about. If you have, so here's our equation, the general form of a quadratic. If a is greater than 0, so that means if a is a positive number, that means our parabola, you could just sketch this, is going to open like this. We say this opens upward. So if a is greater than 0, it's going to open upward, and the vertex is the minimum. So this is one case. Why do we say it's a minimum?
The further what?
It's as far down as it's going to go, yeah. It's not going to go, you're not going to get any values lower than that. Very good. Well, what do you think is true if a is less than 0, if the leading coefficient is less than 0? That means it opens downwards. Means a is a negative number. It would look something like this. So we say this opens downward. And what are we going to say the vertex is now? A maximum. Good. So this is the other possible case. It's all good. That's a lot of information right there. We're gonna learn all about this stuff today. I'm just letting some people get caught up writing. So, quadratic functions make a graph that we call a parabola. Every parabola has an axis of symmetry and a vertex, and the vertex is either a maximum or a minimum. So that's a lot of stuff we just learned right there. Okay? We're just going to build off of this. We're going to keep coming back to it. So for the first example, there's nothing for you really to write down. I just need you to participate with me. Okay? So for the first example, I just need you to watch up here. And do this with me. So we're going to find the coordinates of the vertex of each graph, and we're going to decide whether it's a minimum or a maximum. So let's look at the first one. The vertex. Let me zoom in. Oh, there you can see it. Okay, so can we decide what the vertex is? Where does it live? What's the point that makes the vertex? There's two parts to it. What's the x direction? How much did we go in the x direction? 0. And then in the y direction, we went up 3. So for a vertex, it is a point. It is a location. So you need the x and the y part of it, okay? And now in this one, is the vertex a minimum or a maximum? It's a maximum. It's the highest it's going to get. How do you feel about that? Feeling okay? Let's try another one. The x direction.
1, -1.
1, -1. And is this a maximum or a minimum? Minimum. Okay. Feeling pretty good about identifying vertices for my picture. Okay. Let me zoom this baby back out. All right. So now we're going to graph it. So let's get your graph paper out again, please. And so in the second red square that we have down there, I want you to, so this is like your red square. So here's the equation. We're going to look at this. We're going to decide what this a value, what's going to happen. Okay. So one thing that's helpful to remember is what does the parent function look like? So the parent function, so the first graph that we ever did for these quadratics, it started at 0, 0, and then it was at 1, 1, and then at 2, 4, right? And the cool thing about the vertex of or the axis of symmetry is it has to be the same on the other side. So you see this point right here, it has to be 1 right here. And this one is 2 away right here, so over here it has to be 2 away. So this is the parent function. So go ahead and sketch the parent function on your new axis. So for this one, let's make a table. Now here, I'm going to give you a hint with these, okay? So look at the number in front. Look at our a value. It's a 1/3. So we're going to want to pick multiples of 3 to figure out what this graph looks like. So I would maybe pick -3, 0, and 3. Instead of using 1s and 2s and stuff, because of that 1/3, it's going to make that not as accessible for us. So can we figure out what our y values are going to be? How are we going to figure out what goes right here? Good. So we have 1/3 times -3 squared. So order of ops, what do we do first? Exponents, so what's -3 squared? So we have 1/3 times 9. Well, what's 1/3 of 9? 3. So can we plot that point? -3, 3. Now let's put the 0 in. I love multiplying by 0. It's 0. Okay, so it didn't change where the vertex was. It's still hanging out there. And then let's put the 3 in. So what's 3 squared?
9.
So we have 1/3 times 9. What's it's 3. So what did the 1/3 do to our graph? It's still symmetrical, but what did it do? I didn't hear. Made it bigger, kind of made it open up wider, right? So that's what the 1/3 does. Those numbers in front will change the shape of our graph. And that's what it did. They also asked us to find what the domain and range is. So let's review what this is. And I think you talked about it last year. It's been a while, so let's talk about it again. So domain is everything you can pick for x. Is there any limit on what I could put in for x, for my x value? I could pick any x value I wanted. So your domain is all real numbers. Now the range has to do with the y values. So that's these values right here. So there is, and our vertex is a small point, so there is a smallest y value we're going to get. What's the smallest y value we're going to get? At the vertex, and so the y value is 0. So our range is going to be y's greater than or equal to 0.
So the range is the inside of the thing?
Yeah, it's all the y values that fit inside that. That works. I like that. Okay. I like it. This is good. This is exciting. I'm excited. I don't know if you know that, but I am. I'm trying to contain it. Okay, so the next one is another one where you just kind of got to watch and follow along with me, okay? There it is. So it says use the graphs below, and what is the order from widest to narrowest of the graphs? And they give us the 3, and they give us pictures of them. So which one of these is the widest? The middle one. So the 1/4 x squared is the widest. What's the next widest? The x squared. That's the parent function. And what's the narrowest? And even the negative, what did the negative do? Made it open down. Very good. But if you look at what happens to the number, so the widest is a small number, and the narrowest is a bigger number. So if you have a fraction, our graph is going to look wider. If you have a whole number, our graph is going to be narrower. That's what those numbers in front do. Kind of cool. You can predict what they look like before you even use it. Awesome. All right. So now we're going to put a couple pieces together here. So example 4. So we're going to graph this. This will be on your graph paper, on your third little graph piece of paper. So what is the 2 in front of the x squared going to do? It's going to times it by 2. So is it going to get wider or narrower? Narrower. It's a bigger number, so it makes it kind of suck in. And because it's positive, are we going to open up or are we going to open down? We're going to open up. So we already know some information about this. We got to figure out what this 3 is going to do. So we're going to make a table.
Bring it over x-axis 3 times.
I don't know. We're going to see. So let's go -2, -1, 0, and 1. So I'm going to show you also how to use the axis of symmetry to help you out. Okay. So let's go ahead and evaluate these points. So let's put a -2 in for x. So we're going to have 2 times -2 squared plus 3. So what do we do first? Exponent. So what's -2 squared?
4.
So we have 2 times 4 plus 3. 8 plus 3 is 11. So plot that point. -2. I don't know if I have 1, 2, 4, 6, 8. I don't have 11. Do you guys? I know you have 11 on there, right?
Yeah.
Let's be like her. Mine's off the little picture, but you guys have it. So now let's do the same thing with -1. So do you understand why evaluation is important? Because we're going to be replacing a lot of letters, figuring out what we get out. So we got to be good with our order of ops. So what's -1 squared?
1.
So we have 2 times 1 plus 3. What's 2 times 1? 2 plus 3 is 5. It's right there. Let's put 0 in. I love 0.
Because it's 0. Do we even have to do any work?
Yes. Because what's 0 squared?
0.
2 times 0 is?
0.
But you have 0 plus 3.
Oh, it's
3. And then put the 1 in. So what's 1 squared?
1,
2 times 1?
2.
And 2 plus 3. 5. Now, here's the cool thing about the axis of symmetry. You could tell it's already circled back around. So if this right here is 1 on this side, this has to be 1 on this side. So this point up here, it's 2 away. So this one has to also be 2 away over here. You don't have to evaluate it. You can use your axis of symmetry to help you fill out the rest of it. So here's your graph. So it's narrower. And what did the 3 do?
It brought it up 3.
It moved it up 3. Very nice. So, the plus 3 moved it up 3. Okay, I'm gonna call that good. Here's what I'd like from you. Minus 24. Okay, some of these are match. Some are, look at the graph, identify the vertex. 1, 2, 3, 4, 5. You're going to probably want one more piece of graph paper for your homework.
One more?
Yeah.